Hi बच्चों, this very interesting topic, dominated convergence theorem, and this DCT is basically used to solve some of the JEE advanced questions very easily. Now, what does it state? ये क्या कहता है बच्चों? So suppose ऐसा करते हैं कि let's say some of the functions are there f1, f2, f3, f4 and so on. ठीक है, मैं कह रहा हूं सी दिस कैन बी रिप्रेजेंटेड f1 कैन यू सी हियर, f2 कैन यू सी हियर, f3 कैन यू सी हियर, f4 कैन यू सी हियर. ठीक है, now see these functions are like random zigzag order. They are going somewhere and but they are getting closer to some final target. Can you see here? They are getting closer to some final target. Let's say this call is at f. ठीक है, so what happens if we try to integrate all of this? मतलब what if we want to find, what if we need to find area under them? So this is the basic doubt, area under them. How do we proceed? What's the way to solve? So basically see, this area is getting closer to some final target, and what if we are saying okay, does, if we ask like this, does f and x, because there can be many functions like this, so I am talking of some n, so f n x dx integration where limit n tends to infinity, is it equal to integral limit n tends to infinity f n x dx? If you ask me what does it mean, I'll say in layman terms, what I am saying is, can we swap the integrals? Can we swap the limit and the integral? Both. Can we swap it? So that's the question. And there many questions arises of definite integration where we are required to swap the limit. But what is the condition? मतलब always or not? So here मतलब I can say sometimes we can and sometimes we can't. Sometimes we can't. That is the answer. Can we swap the limit? Yes. Can we swap the limit? No. But when? When does the case arise? So here there comes the important theorem, that is dominated convergence theorem. Dominated convergence theorem, also known as DCT. DCT. But how do we do this? See, suppose if I say you there is a very big positive function. मतलब if I say you it in layman terms, say there is a big positive function, big and always positive function. Okay, say gx. I think if some of you might have seen the graph, you could see there, I would say this as gx, g of x. Okay, now say there is a big and always positive function, that is g of x. Okay, then this gx acts as you can say acts as, I would like to call Gaussian, maybe Gaussian of whom? Of all other functions. All other functions. Which functions? This f1, f2, f3 and all. So it means for every sequence, it's, even if its absolute value I'm talking of is always less than equal to this gx. It means mathematically if I speak, f and x modulus value will always be less than equal to gx, and that is the Gaussian function for all n and for all x. Okay, so here we can see the graph easily. I am saying for any function if you choose this gx, that is the Gaussian function, will always be greater than the modulus of all those functions. Modulus, I am talking of positive, negative, 0, whatever it is. Okay, this will always be greater. But there is one thing. How do we choose the Gaussian angle? The best way to choose this Gaussian angel is like it must be finite. It means gx total area, matlab integral of gx, that is total area, must be finite. Must be finite. You can't choose infinite gx. Otherwise, always there will be one g of x which will be greater than all the functions combined. But we will not be choosing infinite functions. Okay, so it means what type of gx we need to choose? We need to choose g of x dx, and that must be integral of gx dx must be less than infinity. Okay, that means by finite area. Okay, so if you ask me very easily ki what is meant by this dominated convergence theorem, so I would say DCT. Okay, so DCT says if 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 I combine all the 3 points, point wise convergence is there. Point wise convergence. So there were every function that were converging to some point. So I am saying point wise convergence. That is, if f on f of x, fn matlab it means f1, f2, f3 whatever, they goes to certain function f of x as n tends to infinity for almost all x, for all x. Okay, so then there exists we can write like this, there exists a function. What type of function exists? G of x such that f n x mod shall always be less than gx for all n and for all x. Done. Now for the third part we can say, but there is another condition that g of x dx must be less than infinity. That is, we are talking of finite area. So what we got? We got the solution. When can we swap the limit of the integration? So we can only swap the limit of the integration when these 3 points exist. Every function must have pointwise convergence. There must exist a function g of x for which the modulus of all the functions, whether positive, negative, whatever, it must be less than equal to gx, and g of x dx must have finite area. Done. Now why do we need this? Very important, amazing important. Why? See the question. Suppose if I ask you one question, say function f on f and x, okay, they are defined on interval where 0 to 1, that is the interval where f and x is equal to n for x belonging to 0 to 1 by n, and f and x will be 0 otherwise. Suppose this is the case. So what is required here? Let's see whether what we are asking, we are asking limit n tends to infinity f and x dx is equal to limit n tends to infinity f and x dx, whether this is true or not. That is what we are required to find out. So this is our question. So let's check out. How do we check? Now there is a simple way. What is the interval in which it is defined? So it's from 0 to 1, and what is f on f and x? It is n for x belonging to 0 to 1 by n. Superb. So let's say we try to understand one thing. So for 0 to 1 by n, now let's see f1x. So where we are talking of f1, it means we are talking of 0 to 1 will be what? This will be having f on x, f and x is equal to 1. So what is the height? Height 1. मतलब we are talking of area. हमें क्या चाहिए? We are talking of area. So if we are talking of area, height is 1 and width will be 1, so area will be 1 into 1, that is equal to 1. But if I find f2x, now n is equal to 2, so basically we are talking of 0 to 1 by 2. So what is the height? Here the spike will be f and x is equal to n, so height will be 2, and what will be the base? 0 to 1 by 2, so base will be 1 by 2. Superb. So area, that is meant by integration, no, finding the area. So this will be 2 into 1 by 2, that is equal to 1. Now if we want to check further, we can say f and x, this belongs to 0 to 1 by n. So what is the height? So height will be n and base will be 1 by n. So area will be n into 1 by n, that is equal to 1. It means integral of f and x dx will be 1 for all n. So therefore limit n tends to infinity f and x dx is equal to 1. But let's check something more. What do we need to check? Let's check pointwise limit. So what we are talking of? We are talking of pointwise limit. So in pointwise limit, what will happen? Say x equal to 0. Now here what we are changing? We are changing the variable x. So if x equal to 0, then f and 0 will be 0 for all n. Therefore f of 0 is equal to what? 0. Now say if x is greater than 0, suppose. So in this case, if x is greater than 0, however small, whatever be the value, okay, 1 by n, whatever small value this will be, 1 by n will always be smaller than x. Okay, so for large value, so for larger n, large enough n, what is going to happen? F and x will become 0, will tend to be 0. So I will say will tend to 0. F and x will tend to 0. Why? Because if n increases, so f and x will decrease and it will tend to 0. Superb. It means f of x is equal to limit n tends to infinity f and x, that is equal to 0 for all x lying from 0 to 1 both included. Therefore f of x dx is equal to 0 into dx and that is equal to 0. Superb. What does this mean? It means limit n tends to infinity. So what is the conclusion? Limit n tends to infinity, f and x dx will be equal to 0, but limit n tends to infinity, f and x dx was equal to 1. Now this is a contradiction, not equal. It means here we were not able to swap the limit. But what is the reason? The reason is there is no single Gaussian function. There is no single Gaussian function g of x that can dominate all of the cases. मतलब there is no such function, ऐसा कोई फंक्शन एग्जिस्ट करता ही नहीं जिसके लिए एफ एक्स का मॉड से हमेशा बड़ा या बराबर हो जी ऑफ एक्स. ठीक है. सो इसका मतलब क्या हो जाएगा कि इसीलिए इंटीग्रेबल डिनोमिनेटर जिसको कहेंगे, या फिर ऐसा कह लो इंटीग्रेबल डिनोमिनेटर नहीं, डोमिनेटर जो फंक्शन है वो है ही नहीं, दिस इज नॉट देयर. सो दैट्स वाई. तो रीजन क्या था? देयर इज नो सिंगल गॉसियन फंक्शन gx that can dominate all of the cases. ऐसा कोई फंक्शन है ही नहीं अवेलेबल, इसीलिए इक्वल नहीं है. अच्छा, लेट्स से अनदर केस. नेक्स्ट क्वेश्चन. से कंसिडर अगेन अ बिट सेम, कंसिडर f and x on real line. Okay, suppose on real line what is the condition? F and x equal to 1 if x belongs from n to n plus 1 both included. Otherwise f and x is equal to 0 otherwise. So what we are required to check? Check if what limit n tends to infinity f and x dx is equal to limit n tends to infinity f and x dx. So how would we check it? How do we check? See here, condition is f and x has bump of 1. Okay, so it has height 1. It means since f of nx is equal to 1, so for every f and x height is 1 and width 1. Why width is 1? We are choosing, see, we are choosing from, suppose if we are putting f2x, so we are choosing from 2 to 3, then we are choosing from 3 to 4, then we are choosing from 4 to 5. So every time the width is 1. So height is 1, width is 1, therefore area is equal to 1. So area is 1. Now hence we can say limit, even if you tend to infinity, f and x dx will be equal to limit n tends to infinity 1, which is equal to 1. Superb. But as n tends to infinity, what happens with the other case? So this interval, the interval n comma n plus 1 will cross x somehow, because see, for f, what is written here, f and x on real line. Okay, so if x belongs is an element of n to n plus 1, but what is going to happen at some point of time, if I move n towards infinity, this interval n comma n plus 1 will always be greater than x for some point of time. So therefore what is going to happen? Limit n tends to infinity, f and x will be equal to 0 for all x after this case. So it means fx dx limit n tends to infinity is equal to 0. Now why this case? Again, why not equal? So see, when the cases cannot apply, why not equal? So f and x was dominated by gx equal to 1. Okay, because every number, every limit, even if it tends to infinity, f and x dx has an area which is equal to 1. So it is dominated by gx equal to 1. But gx is not integrable. Over entire line. Actually there will be bumps. So for all integral line it is not integrable. It means minus infinity to infinity 1 dx will be equal to infinity. Why? Because at some point it is not integrable. So therefore this 1 dx will not have a finite area. So it will be infinity. Why? Because see, the width will become infinite and hence the area will become infinite. So there is no integrable Gaussian function. No integrable Gaussian function. So now how do we apply this? Let's see. Suppose if I give you the question. Suppose if a question is given nx square by 1 plus n square x to the power 4 dx, limit n tends to infinity, and this goes from 0 to 1. So this is question number 3, I guess. Yeah, this is question number, sorry, this is 1, next one is 2, and yes, the last one becomes third one. So this is question number 3. So how do we proceed with this? So given is nx square divided by 1 plus n square x to the power 4 dx. Now how do we find? So if we don't use dct, what is the approach here? Since limit of n tends to infinity, it means the integrable function also depends on n. Now this is the problem. So how do we integrate this? Directly we cannot integrate. So instead, like this, what we are required to do, let's say fn x. What is the value? Fn x is equal to nx square by 1 plus n square x to the power 4. अब ऐसा करते हैं, we find limit as n tends to infinity. If n is tending towards infinity, we are finding the limit. So what is the limit? Say if x is equal to 0, then fn 0 will be what? x 0 है तो 0 by 1 and that is equal to 0. What if x is not equal to 0? If x not equal to 0, then fn x can be written as, now x is not equal to 0, what we can do? We can divide numerator and denominator by n. So we can say x square divided by n square into n. So this will be n, and here 1 by n square plus x to the power 4. Now x is not equal to 0. So as n will tend to infinity, x square by n will tend to 0. 1 by n square will tend to 0. So therefore this will become, so f of x limit n tends to infinity, fn x will be equal to 0 by x to the power 4, which is equal to 0. Done. So therefore fx equal to 0 for all x that belongs from 0 to 1. ठीक है. So अगर if I use the integral, suppose now if I use dct, so what will happen? If I use dct, then the integral will be 0. But what is the way to solve this? So what is the way to solve this? Let's see. What is the way for dct? The way is to find Gaussian function. So what can be the Gaussian function for this? What is the Gaussian function? So for the Gaussian function, what we are required to do? Fn x का mod is less than equal to gx, and integral g of x dx is less than infinity. That is what we require. So how do we find this? It means find something which is independent of n. So fn x, what was there? nx square by 1 plus n square x to the power 4. Now what we can do? 1 plus n square x to the power 4 is always greater than equal to, am is greater than equal to gm, yes or no? Greater than equal to gm. So this will be 2 ab. A plus b is greater than always equal to 2 root ab. So this will be 2 n square x to the power 4. So basically this is equal to greater than 2n x square. Done. Now n and x are non-negative. That is what we are talking of. So we can say that if I invert it, so this will be 1 by 1 plus n square x to the power 4 is less than equal to 1 by 2n x square. Done. Now therefore fn x का mod shall be equal to nx square by 1 plus n square x to the power 4, which is always less than equal to nx square divided by 2n x square, which is equal to 1 by 2. So it means therefore fn x का mod is always less than equal to 1 by 2 for all n and for all x that belongs from 0 to 1, both included. So therefore Therefore, gx will be equal to 1 by 2. Gx is 1 by 2. Now, if gx is 1 by 2, we know gx dx is integrable from 0 to 1. Why? Because 1 by 2 into x 0 to 1, which is equal to 1 by 2. So this is finite. Okay. Now all the conditions are met. What were the conditions? First, f and x tends to 0 pointwise for x that belongs from 0 to 1. Next, f and x mod less than equal to 1 by 2 for all n and x. Third, half of 1 by 2 dx integral 0 to 1 is equal to 1 by 2, which is less than infinity. So we can apply directly limit n tends to infinity 0 to 1 nx square by 1 plus n square x to the power 4. We can use what? DCT. So this will be 0 to 1 limit n tends to infinity, and this will be nx square by 1 plus n square x to the power 4, and dx which will be equal to 0. Why? We calculated it before. Okay, this value is 0. So this value is 0. Hence 0 dx. So this will be 0 dx integral, and that is equal to 0. So this is the solution. So now if you are not knowing DCT, it is really very difficult to find out the solution for this. Did you understand why DCT is used? Superb, amazing. Let's see next question. Next, what if I say second is evaluate? No, this is not second, this is fourth number. This was question number 3, and here this is 4. Yeah, question number 4. So question number 4 says evaluate limit n tends to infinity 0 to infinity n sine x by n x 1 plus x square and dx. So how do we go for it? What's the way? Again, now limit is outside. If we can swap the limit, that is what we need to check. So let us see. First we will check the function f and x is equal to n sine x by n divided by x 1 plus x square. Done. Now where we are integrating? We are integrating from 0 to infinity. Okay, so let's find the limit. We know that if limit t tends to 0, sine t by t is equal to 1. This is what we know. So what we are required to do? We are required to find f and x. Matlab find, first thing is find pointwise limit. So if I find pointwise limit, it means f and x as x n tends to infinity. So if we consider, let t is equal to x by n. So as n tends to infinity, x by n will tend to 0 for fixed x, if the x is fixed. Done. Now what we can do? F and x can be written as n into sine x by n divided by x into 1 plus x square. Done. So this can again be written as sine x by n. This n can be taken down, so this will be again x by n into 1 plus x square. So as n tends to infinity, now if I say limit n tends to infinity, it can purely be stated x by n divided by x by n, it will tend to 1. Why? Because if n tends to infinity, x by n will tend to 0. So this will become 1. This will tend to be 1. Not exactly 1. This will tend to be 1 for x not equal to 0. If x is not 0. Done. So term remains this one. Therefore, if x greater than 0, then f of x limit n tends to infinity f n x is equal to 1 by 1 plus x square. Now if x equal to 0, then fn 0, check in the original form. If as x tends to 0, so for fn x, if I say x tends to 0, in which form shall I say? We can say n into x by n. So if I put here fn n, or don't say exactly x equal to 0, we can take another thing. We can choose x tending towards 0 for fn x. So this will be n into x by n divided x 1 plus x square. Okay, why like this? So sin x can be approximated as x if x is tending towards 0. So therefore we can say like this, this gets cancelled, this gets cancelled. Again this is 1 by 1 plus x square. Superb. Now what does it state? That is x greater than or equal to 0. This limit tends to 1 by 1 plus x square. Now what is the dominating function? So how to find? Step 2, find dominating function. That is we can say this Gaussian function. So if we find dominating function, we already know that sin t is always less than or equal to mod of t for t belonging to R real numbers. Okay, so this implies that sin t by t ka mod will always be less than or equal to 1. This implies that. Now if t is equal to x by n is equal to t, where x greater than or equal to 0 and n greater than or equal to 1. So this will be implied. And there can be another case. I can say this mod, so x by n is an element from 0 to pi by 2. I can choose like this, so that sin x by n divided by x by n always tends to be less than or equal to 1. Okay. What happens here? You will say, Miki, why you have taken, sir, from 0 to pi by 2? I can take another value, say x by n is greater than pi by 2. So what's going to happen? Then we can say mod of sin x by n will always be less than or equal to 1. That's not a problem. This is always less than or equal to 1. But what is going to happen with sin x by n by x by n? So this will be less than equal to 1 by x by n, which is equal to n by x. So this will be less than equal to n by x. So remember this. Done. So it means boundaries can be different. Boundaries can be different for x. If x is different, so boundaries will be different. Okay. So basically we can say n sin x by n, which is written for the numerator part of here, n into sin x by n. In the original question it is written n into sin x by n. So basically mod can be less than equal to mod of n into mod sin x by n, which is less than equal to n into x by n. Why? We are considering sin x is approximately nearby equal to sin x by n, which is equal to x. So therefore fn x mod is equal to n sin x by n divided by x 1 plus x square mod, which is less than equal to x by x 1 plus x square and is equal to 1 by x square for x greater than 0. Then and for x tending to 0, if x is equal to 0, it means it will also behave like 1 by 1 plus x square, that we have seen nearby to the zeros. So our dominating function gx will be decided as 1 by 1 plus x square. Done. Now What is the integral? We have to check whether it is finite or not. Now integral of 0 also, integral of 0 to infinity 1 by 1 plus x square dx, we know this is equal to tan inverse x, and tan inverse x from 0 to infinity, this will be equal to pi by 2, which is less than infinity. So this is integrable. Hence the value limit n tends to infinity. So limit n tends to infinity 0 to infinity n into sine x by n divided by x into 1 plus x square dx is equal to 0 to infinity limit n tends to infinity n into sine x by n by x into 1 plus x square dx. So this basically says the value as tan inverse x 0 to infinity, which is equal to pi by 2, and this is the answer. Done. Understood? So this is the use of DCT, dominance convergence theorem. At the end, I would give you certain questions to check, evaluate limit n tends to infinity ln 1 plus x to the power n dx by x. Again, I would say another question says limit n tends to infinity 0 to infinity n e to the power minus nx square dx. Again, another question, third one says, suppose if I give you limit n tends to infinity 0 to infinity e to the power minus x by n 1 plus x square dx. So these are the three questions for practice. You can do it and post it in the comment box. Done. Thank you.